Greetings, YouTube. Sorry for the delay this morning. Hope all is well. Beautiful mind here. This will serve as a lecture for week 5 Wednesday for support for college algebra. Let's see. So again, I hope all is well. So we had exam 2 this past weekend. Be on the lookout for quiz. I think it's going to be quiz number 3 for week 5. So that'll be available shortly if it's not already available on Pearson. Actually, I think that's it really. So for this week, it's business as usual. We have our assignments via Pearson, and be on the lookout for a quiz via Pearson. Be sure that you've completed the participation and honesty quiz via Moodle. If you have questions, I'm available. Just reach out to me. I think we did a starfish update. So I will probably over the next day or two, I'll be going through just trying to clean house. Everyone should have full access. If you don't have full access to Pearson, reach out to me. I've been kind of going back and forth with our Pearson rep. We're supposed to have complimentary codes, and so I know that some students kind of waited and their codes expired, so now we're waiting again to get another code. But everyone should have full access, complimentary. Okay. With that, we're just going to go ahead and move into today's lecture. So today, I'd like to continue chapter 9 with roots and radicals and move into section 9.2, simplifying square roots. Okay. So some objectives here are to use the product rule to simplify square roots containing constants, and use the product rule to simplify square roots containing variables. So the product rule for square roots, if we have the square root of a times b, this is going to be the same as the square root of a times the square root of b, and vice versa. If we have the square root of a times the square root of b, we can condense that into one radical to become the square root of a times b, provided that a and b are non-negative, so greater than or equal to 0. This is rule number 1. Okay. So to simplify square roots of a constant, write the radical as a product of the largest perfect square factor and another factor. Use the product rule to write the expression as a product of square roots, with each square root containing one of the factors, and determine the square root of the perfect square factor. For me, that explanation is just easier seen in action. I'd rather just kind of work through an example or two to see that. So for instance, we're asked to simplify this. Bada bada boom boom. Okay, let's do this. That's nice. We'll use this color. Okay. Let me think about it. Okay, so let me see what they said. Oops. Clear the ink. Let's turn this off. Let me see what they say. Write the radical as a product of the largest perfect square factors. Use the product rule. Okay, I get it. Okay. I'm not gonna do this exactly the way that previous slide did it. I'm gonna do it the way that I'm comfortable doing it. So first we're gonna do the prime factorization of 60, right? So then 60 is what times what? Off the top of my head, I see 6 and 10, right? So 60 is 6 times 10. But then 6 breaks apart into what? 2 times 3, and 10 breaks apart into 2 times 5, right? So I'm going to rewrite 60 as the square root of 2 times 2 times 3 times 5. Okay. Let's see. So since we're doing square root, we're looking for groups of 2. So here's the only group of 2 that we have, right? So from there, 2 times 2 is 4. So we're going to say, we're going to have the square root of 4. And then times the square root of 15, right? The square root of 4 is what? 2. So there's going to be 2 times the square root of 15, and that's as far as we can go. Okay. Okay, we got 2 times the square root of 15. Give me a moment. Let me think about it. I'm pausing because I want to, I can see it there, so I guess that'll work. Okay. So I'm going to clear these notes. Clear these markings. So what the notes have, list of positive factors is 60. These are the factors. The only perfect square is 4. Okay, that's fine. So then 4 times. So they essentially did do it the same way that we did it. Let's do it again. Let's do another one. Okay, so we're asked to simplify the square root of 175. Again, so again, this is how I would do this. So then 175, well, I automatically see that it's divisible by 5, so I'm going to say 5 times something. Let me see. That's a 15, so that would be 3 and 5, right? So 175 should be 5 times 35. But then the 35 breaks apart into 5 times 7. And then we're just going to bring this 5 down. All right, I think that's it. So we see that 175 is going to be the square root of, we have 5 times 5 times 7, right? Notice that the 5 times 5 is a perfect square. So that's the group of 2 that we were looking for here. We're doing group of 2 because we're doing square root. Because we're doing square root, we want groups of 2. If we were doing cube root, we would do groups of 3, right? But this is our perfect group of 2. So then what we're going to do, this is going to be equal to the square root of 25 times the square root of 7. What's the square root of 25? That's going to be 5. And then we're left with the square root of 7. Okay. And I think this answer is good. Okay. I think they did the same thing we did. All right, let's do another one. So then 135. Now this would be a good time to pause the video and try it yourself. See, can you arrive to, like with all of these examples, pause it first. See if you can arrive to to your own conclusion, and then start the video to see if you get to the same conclusion. Again, the more you can do on your own with the least amount of support, the better off you'll be. It's okay to have support, but eventually you do have to start doing it on your own at some point. All right. So I do see that it's divisible by 5, so it's going to be 5 times, let me see, that's a 27, right? But then 27 is what? 3 times 3 times 3? Spiritual Scholar. 3 times 3 times 3. All right, 9 times 3, okay. So then this 135 is going to be the square root of 3 times 3 times 3 times 5, right? Since we're doing square root, we're looking for groups of 2. And so here's one group of 2. So we're going to rewrite that as the square root of 9 times the square root of 15. And the square root of 9 is what? 3 times the square root of 15. Okay. You see it here. All right. So then rule 2, say we have the square root of a to the power of 2n. That's going to be equal to a as long as a is non-negative, greater than or equal to 0. Okay. So notice in this rule, we essentially divided the exponent by 2. Since we're doing square root, we're dividing the exponent by 2. That's essentially what we're doing there. So for instance, for these, since I'm saying the square root, 10 divided by 2, this is going to be the same as x to the power of 10 divided by 2. So that's going to be x to the power of 5. Okay. This is going to be the same as the square root of x to the 6 times the square root of y to the 12. And then 6 divided by 2 is going to be x cubed. 12 divided by 2 is going to be y to the power of 6. Okay, this is going to be a squared b to the 4 c to the 5. I just divided all the exponents by 2. This is going to be a b squared c cubed d to the 4. Okay. All right. To simplify square roots of a radical containing a variable raised to an odd power, express the radical as a product of two factors, one of which has an exponent of 1, the other therefore have an even exponent, and then use the product rule to simplify. All right. Okay. So if I were doing this one, right? So 72, I'm going off to the side, I would do 72 is what? Is that 9 times 8? Okay. So then this is going to be the same as the square root of, let's see. So then 2 times 2 times 2 times 3 times 3, 9 times 8, all right? Times x squared times y. We're still looking for our groups of 2. So here's one group of 2. Here's a second group of 2, all right? So then it's basically going to be, we have the square root of 4 times the square root of 9. Those are the groups of 2 that we found. And then we're going to say times the square root of 2 times the square root of x squared times the square root of y. Okay, I want to highlight our perfect squares. That's going to take in green. Square root of x squared. Okay. So then this becomes 2 times 3 is 6x times the square root of 2y. Okay. So 45. 45 is what? 9 times 5? So we have the square root of 9 times the square root of 5. So then x to the power 3, we're going to break it apart. We're going to say that's the same as the square root of x squared times the square root of x. Oops, let's do like this. Square root of x. And then we have this square root of y to the 4. Okay, so my perfect squares, I did them in green, so they would stand out. The square root of 9 is 3. Nope. The square root of 9 is 3. The square root of x squared is x, essentially. And the square root of y to the 4 is going to be y squared. And then what's left inside the radical is the square root of 5 times x. Okay. All right. 98. We see that 98 is at least divisible by 2. So there's going to be 2 times, let me see, 49. And then 49 is 7 times 7. That a to the 9 we're going to rewrite as a to the 8 times a. And then times b to the 6 times b. All right, we want to take the square root of all of that. So then this is going to become, let's see, we're going to have the square root of 49 times the square root of a to the power of 8. And we're going to have this square root of b to the power 6. And then the square root of 2 comes down. The square root of a comes down. And the square root of b comes down. And we'll finish with 7 a to the 4, b to the 3 times the square root of 2ab. 2ab. Okay. Let's see, how do we do? So we got 6x times the square root of 2y, 3xy squared times the square root of 5, 7 a to the 4, b to the 3. Yeah, this looks good. Okay. Okay. So multiply and then simplify. Let's see, do I need more space? Okay, I'm going to stop switching colors. So then let's see. 8 times 4 is what, 32? So this is going to be the square root, the same as the square root of 32, x to the power of 4, y to the power of 6. But then that's the same as the square root of 16 times 2 times x to the 4 times y to the 6. The square root of 16 is 4. The square root of x to the 4 is x squared. And the square root of y to the 6 is going to be y cubed. And I think we're left with that square root of 2 is the only thing that was left inside. Okay. This next one, 6 times 7 is 42. A to the 6, b to the 9. I'm going to take the square root. So 42 is 6 times 7. There are no perfect squares there because it's going to be ultimately going to be 2 times 3 times 7. So there's no perfect squares there. We do have one with the b. So there's 42. A to the 6. We want to change that b to the 9 to b to the 8 times b. Okay. So then ultimately, a to the 6 becomes a cubed. B to the 8 becomes b to the 4. And then we're left with this 42b inside the radical. Okay. Okay. All right. So give me a moment, and I'm going to load the next section. All right, and we are back. Okay. Good chaka. So I'll make sure that assignments are posted, available, corresponding to these lectures. More than likely, I'll do 2 lectures on Friday as well, and I'll go ahead and load a quiz and an exam. Sorry, homework and a quiz. So this is what, week 5. So we can anticipate exam 3 at the next week, right? I'm making all these sound effects. I was listening to myself. Anyway, but yeah, so be ready for exam 3 next week in week 6, right? Yeah, that's usually when I like to do it. Yeah, exam every other week, and then the last exam will be the final. I might get the final up a little bit early because I want to give you time to actually do it. I don't want it to be at the very, very last second. So, yeah. So week 7 and 8, I'll probably get the final up by week 8, and then the last day we have like 8.5 weeks, right? Okay. So let's we're gonna go ahead and do section 9.3. That's not what I want. I don't know how to get that to go away. That's okay. So we're going to continue chapter 9, moving into section 9.3, adding, subtracting, and multiplying square roots. So some objectives here are to add and subtract square roots and to multiply square roots. So what do we mean by like radicals and like square roots? Like radicals are radicals that have the same index and the same radicand. Like square roots are square roots that have the same radicand. We add and subtract like square roots in much the same way that we add and subtract like terms. All right? So simplify if possible. So for instance, if we look at the radical, they're both square root of 3, right? So this is just, if we say 2 root 3 plus 5 root 3, we would add it in the same way that we would add 2x plus 5x to give us 7x, right? So this is going to be 7 times the square root of 3. Okay. Notice that these radicals are not the same, so we can not like radicals. These are not like radicals. Ugh. These are not like radicals, so we can't add them. We can't add. Okay. Let's see. So we have a square root of 11. We got 5 root 11 minus 3 root 11. Those two can be added. So then 5 minus 3 is going to be 2 root 11. And then that plus 1 just stays. And we can combine like radicals. So 4 root 6 goes with 1 root 6 to give us 3 root 6. And then 2 root 7 minus 8 root 7 is going to be what? Negative 6 root 7. And then at this point, we have unlike radicals that we cannot add. Okay, these look good. Okay, I think we got all these results. So unlike radicals, unlike square roots, are radicals that have different indices or different radicands. Remember, radicand is the part inside the radical, inside the root. Unlike square roots are square roots having different radicands. Okay. It is sometimes possible to change unlike square roots into like square roots by simplifying the radicals in an expression. After simplifying, square roots that contain the same radicand can be combined. Okay. That's a little bit of foreshadowing or forewarning. Let's see what happens here. So notice that these are unlike radicals because they have different radicands, but let's simplify each one, right, and see what happens. Okay. The square root of 8 is 4 times 2. So ultimately, that's going to be 2 times 2 times the square root of 2. 32 is what? 16 times 2? The square root of 16 is going to be 4 times the square root of 2. All right. I kind of skipped some steps there, so you should be able to. So then ultimately, we're going to get 4 root 2 minus 4 root 2. It looks like that answer is 0. 0 is good. So notice that 8 is 4 times 2. 32 is 16 times 2. The square root of 4 becomes 2. The square root of 16 becomes 4. 2 times 2 is 4. And we get our 0. Okay. Let's keep it moving. All right, let's simplify these and see what happens. So then 12 is what? 4 times 3? So let's write that out. So this is going to become 3 times the square root of 4 times the square root of 3. Okay. 27 is 9 times 3, so we're going to have the square root of 9 times the square root of 3, and then we're going to have plus 6. I said 2, 3 times 2 is, it's going to be 6 root 3. 5 times 3 is 15, so plus 15 root 3 plus 6. That's going to be 21 root 3 plus 6. Okay, that's good. Okay. So let's break these down. So off the bat, I see that 120 is 12 times 10. So let's see, 12 times 10. 12 is 4 times 3, so let's do 2 times 2 times 3. 10 is 2 times 5. Okay, that's the first one. 125 is what, 5 times 25? So that's going to be 5 times 5 times 5, right? If we look for groups of 2, let's see. Here is the only group of 2 there, and here's a group of 2 here. 12 was 4 times 3. 10 was 2 times 5. Yes, I was hoping it would go a little further, but maybe it won't. So this is going to be square root of 4 becomes 2 times the square root of 30 minus 5 times the square root of 5. So I think that's as far as we can go there. These are unlike radicals. Okay. So multiplying square roots. The distributive property can be used to multiply radical expressions. When a distributive property is used, each quantity within the parentheses is multiplied by the number preceding the parentheses. Multiply the expression using the FOIL method. Okay, what does FOIL stand for in this context? So FOIL in this context stands for, it stands for first, outer, inner, last, right? So then the first times the first, so this times this is going to give us 12. Outer times outer, 3 times 2 is going to be negative 6 times the square root of 5. Inner times inner is going to be plus 4 times the square root of 5. And last times last, that's going to be minus 2 times the square root of 25. Okay. So then the 12 just comes down. We got a negative 6 root 5 plus 4 root 5 is going to be negative 2 root 5. Square root of 25 is 5 times 2 is going to be negative 10. Oh no. Okay, negative 10. 12 minus 10 is going to be 2. So this is going to be 2 minus 2 root 5. I think that's as far as we can go there. Okay. Okay. All right. So that is enough for one day. Let me think about it. So again, just be on the lookout. I'll probably go ahead and load assignments at least through 9/5, and I might go ahead and do a quiz for the week. Keep in mind that these assignments are due this Saturday by 11:59. Every week, the assignments are due Saturday at 11:59. Okay, that's how I take your attendance. So when I see that you're doing the work, I give you attendance credit for that week. Otherwise, then we play a different game. Okay. We're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.